Welcome back. In this video, we will continue our SOLIDWORKs modeling practice by working through example part. Each lesson in this series is designed to reinforce the same core skills, interpreting drawings, creating fully defined sketches, and building accurate 3D models, while gradually increasing the level of complexity. All reference materials and example files used in the series come from SDC publications, specifically the official guide to certified SOLIDWORKs associate exams. Using the corresponding downloadable files will allow you to follow along with the exact exercises demonstrated. For the next few videos in this series, we will be reviewing the provided drawing, establishing the initial sketch, applying dimensions and relations, and building the required features step by step. Let's open a new part file and get started. Okay, now for our first tutorial walkthrough, I'm going to go ahead and drag this picture over. This is the one that I'm going to be using. It's tutorial 3.1. I'm not going to leave this picture on the screen. I'll probably just put it up somewhere. But in SOLIDWORKs, starting from scratch, we're going to go to File, we're going to create a new part. Okay, once we have opened up our new part file, go ahead and save it to your project folder, and that way it's already saved from the start. We don't have any issues. Okay, once you have named your file, go ahead and save it to the folder of your choice. I have it saved here, and then I already saved it once. I'm going to just replace it. Now we have saved. Now we can go ahead and begin modeling. Let's go ahead and make our reference planes visible, and then switch over to the isometric view. This is how I always start all of my new models. And now from here, as we can see, the in any engineering or machine drawing, like the one that we see here, it's presented to us in the isometric view. When you're going to recreate a machine drawing or engineering drawing in SOLIDWORKs, you have to make sure that you are recreating it as exact as possible. Something one of my professors told me was that you can't make your part look like it, it has to be it. And that's a very strong statement that I remembered from him. Okay, before we start sketching, we can see here that they have dimensions in terms of variables as A and B, A being the entire length, B being the entire height. So to edit these variables into our part file, we're going to need to open up the equations global variables table. I have a keyboard shortcut for it that I created. Mine is Shift Q. If you don't have that, you can go ahead and just click on the equations, right click, manage equations, and the same table pops up. From here, we're going to go ahead and establish global variable A is going to be 3.3 inches. As you can see, the unit is in IPS, so inch pound second. And then select our unit, inches, and then we can go ahead and just say that this will be the length. And then we're going to establish global variable B. This is going to be 2 inches, and then this is going to be the height. Just press enter or press OK. Now that we have established our variables, let's go ahead and go to the front plane, start sketching, either by clicking the front plane directly, or you can click on the feature manager tree. And then I'm going to go ahead and just draw a huge rectangle. And then if you hold down the right click button on your mouse, scroll up, you can see you have a few options that you can choose from this gesture wheel is what it's called. I'm going to go ahead and do the dimension tool. There we go. And then this was global variable A for the length. Press the check mark. And then the height on the left side was global variable B. Now that we have established our variables, I'm going to go ahead and smart dimension the top line to the top plane. And then this is going to be half of the global variable B. So if we press equals B divided by 2, then it sets up an equation here as well. And now it'll relate the top line to the top plane, and it sets it at the halfway point of this length here too. So it's just one. And then we're going to do the same thing for the length. And now we have a rectangle where the center of mass is aligned with our origin on our model. So we can go ahead and just press the check mark here, go into our isometric view again, and then click on the sketch, and then we're going to go to features and then extrude boss. And then we're going to do midplane, and then the total width of the part is 2.25 inches. Now that we have established our quote-unquote raw material, it's also a good practice to like name your features so that way you understand like what you were doing at this time if you were to come back to reference it later. I like to label things in all caps, just a me thing. Now I'm going to go ahead and remove our reference planes, and then we can go ahead and start cutting away at this material. Alright, so we're going to click the front face of our raw material, and then we're going to press sketch. There's one of two ways that you can continue sketching from this point forward. You could either sketch the material that still exists, or you can do your best to sketch the material that you will be cutting away. I choose to sketch the material that will be cutting away. So I'm going to start from this right-hand corner, and then I'm going to come down to some length like this, and then we're going to have another cut here, kind of like that. So now we have our stair effect. And then going to our smart dimension tool, we know that the length from this line to this edge is 0.75 inches. And then we know the height of this line is 0.5 inches. And then we know the length of our first box here, I'll probably do it at the top line, is 1.75 inches. And we know the height from the bottom face of our raw material to this line, 0.75 inches. Alright, and that gives us all the dimensions for the cut that we will be doing here. So we can go ahead and press the check mark. And since it's still hided already, we're going to go ahead and just press extrude cut. Go into our isometric view. And then we're going to be cutting from our sketch plane in the direction outward. We just have to select our contours. So I want to cut out this material, cut out that material. And then press check. Now we get this part of our drawing. And then after this, I'm going to select the face right here, press sketch, and then we're going to cut out that little square area, this corner this way. Then I'm going to smart dimension, and it's just 1 inch by 1 inch. Then press the check mark, isometric view, extrude cut. And here, you don't really have to specify a length. We can just go ahead and do either through all, and it comes down like this. You can do through all both if you still had material on the top, or you can do up to surface, which is what I normally do, and then I select that surface. And I'm going to uncheck direction 2. And now we have our perfect little cut that we're going to do. Press the check mark. And then this is the part as we see it, and then we just have to assign a material, 2014 alloy. So go to material, right click, edit material, and I'm going to just go ahead and type in 2014, and it's right there, 2014 aluminum alloy. Press apply, and as we can see here, it gives us the density of the material at 0.101 pound inch cubed. And then if we go here, our density is being displayed in the SI units, so we can go ahead and change it to English. And then as we see here, mass density 0.101 pound per inch cubed. And that's how you know that we've selected the correct material. Press apply, close. The color should change a little bit. This color is kind of similar to the default one. So one of the things that this, from our reference material here, the picture, one of the things that it does not include is the origin on the part. I just kind of assumed that the origin was going to be at the center of mass of that rectangle, where it is right now. But in order to determine if your answer is correct, they establish an origin that was about this point right here. So we're going to need to establish a new origin. That way we can evaluate our part, evaluate the mass properties at that specific origin. In order to do that, we can go ahead and do reference geometry, and then we can do another coordinate system. Then we're going to select this corner down here. And we have to make sure that our directions are aligned. So our positive x direction is going to go in this direction, and then the positive y direction is going to be going up. And we're going to flip it. Now this orientation is the same as this orientation. That way nothing changes. Go ahead and press the check mark. I'm going to go ahead and give it a name. Call this reference origin. Okay, and now when we go to our mass properties, we're going to evaluate with respect to our reference origin. And now from here, this is our center of mass location. And I'm going to display the correct answers on the screen. So these match, and then our mass also matches. These are the two that they're going to be asking you for. They might also ask for volume. And as we can see, everything matches exactly as it is. So 29.88, these match identically along with the mass and the volume. And that's how you know you have created the part correctly. Alright, that concludes our first modeling exercise in SOLIDWORKs. In this lesson, we reviewed how to interpret a part drawing, create a fully defined sketch, and apply essential features to produce a complete 3D model. These foundational skills will be used repeatedly as we move into more complex designs. In the next lesson, we will continue building on these fundamentals and introduce new tools that will expand your modeling capabilities. Thank you for watching. I'll see you in the next session.